Alright, so here are some exercises from the book for simple interest. I'm going to do these four that are highlighted here. I already wrote down the correct answers, which I found right here in the solution manual, which I have. So notice these are basically what you do is multiply the principal times the rate, 12% for example here, times 7 years. You come up, this is the simple interest, and then you add the original principal to it, and there's then that result, which is the future value of the investment. I'm going to show you how to do it on the calculator. So first one, there we go. The rate of 6.5% needs to be divided by 100 to get it as a decimal, times the 6. Here it is, 1,950. Add the principal, and there's the 6,950. And then I do this one here. That's probably not going to be quicker by me doing this. And this one is going to be 12%, so I have to write 0.12. Get rid of that. Yeah, that's actually not quicker at all. I should have just retyped the whole thing. There we go. I think it looks okay. Add the original 3,500. There we go. Whoa! All right. Sorry. Go back to, there we go, 2,940. And now, fix this one here. Notice that I meant to write plus, and I didn't. So there we go, 6,440. Then, yeah, as I said, it's actually quicker if I just type this. It's that convenient. So times 0.115 times 10. I'm going to add the principal already here, saves me one step. There we go. And there's the correct answer, 16,770. And the fourth problem that I wanted to do is this one, times 0.01. Oh. Okay, sorry, start over again. I made a typo and then I have to start over again, I guess. Times 0.0. Keep making typos. 488. I don't know where I kept getting that 1 from. Times 4 years plus the original principal investment. And there's that 74,700. And then, of course, yet another method is to use this kind of Excel or sheet or any kind of spreadsheet. So here would be, for the first problem, the $5,000. Interest rate 6.5% was the first one. Term length, for my spreadsheet, that term length really doesn't make a difference, but I might as well type it in here anyway. And then I would look at 6 years, and there we go. There's that 6,950, which you see up here. And the next one would be, let's see, 3,500. And then this one is 12%. And this one is 7 years. So I'm going to look at here, and there it is. And the next one is, oops, not 8,000, 7,800. 11.5%, 10 years, and then here, there it is. And the last one that I want to do here for simple interest is 62,500, 4.88%, 4 years, and there it is. So in this spreadsheet here, what happens here is I just put the percentage in, but you might have see this one here is a little bit hidden. That's where I divide by 100, because my percentage has to become a decimal. And then let's see, this is 4 years here. And then the formula is this one here, which says, okay, multiply the original principal here times the rate, which already is divided by 100, times the number of years that I put in. Okay, and then actually add the principal again. That's what the 1 plus in parentheses is about. All right. That's for a few examples for simple interest. So here are a few examples for compound interest. Following exercise, compute the future value of the investment with the given conditions. So, for example, $15,000, 4.25% compounded annually for 5 years. Top of my head, if this was simple interest, then 4% times 5 years, approximately 4% times 5 years would be 20%. 20% of $15,000 is around $3,000, which I add to the principal, and I come up with $18,000. So notice, if this was simple interest, yeah, $18,000 compound is, of course, a little bit more. And of course, I just made an estimate, with the simple interest. So ballpark figure I just came up with. So let's do it a little bit more accurate. Let's see, I'm going to try to not hide this. I guess it's going to stay there. So here's the solution manual where I already copied the numbers. Maybe I copied them correctly to the nearest cent. I think so. It was like in the neighborhood of like 25 digits that I had to type. So there we go. And then calculating. This was the one from earlier from the simple interest. So here we go. This is what I have to calculate. So take the original principal, $15,000, the original investment, times parentheses 1 plus, and now it gets interesting. So rate of 4.25% again becomes 0.0425%, and it's annually, so I don't have to divide by anything, so I just close the parentheses. And now I'm going to do to the power, and that would be how many times per year it's being compounded. Well, only once because it's annual, so I just have the 1 there times a total of 5 years, which means I could have left out the 1 times there in this case, and I come up with the correct answer: $18,470.19. Okay, if you round to 20 cents, which would be actually a little better, that's fine. The bank, of course, would be really particular about that, but in my case here, I just round, or the solution manual rounded down. So it's all good. That 1 cent there won't bother us. The bank, yes, not us. All right, let's see. Maybe this time around I can just hit the second entry button here and fix my numbers for the next one. Early on I was kind of slower doing it this way. Let's see what happens now. So this one is going to be 3.75%, there's 3.7, and then it's going to be 10 years. I'm going to get rid of that 1 there, I don't need it. So 10 years, there we go, close the parentheses, which in this case I didn't need, oh well. Enter, and there's that $39,738.70. I guess maybe the bank does round down. Okay, for the next one I actually will retype it. Notice that I skipped prompts, the next 2 prompts. I'm going to go to the next one where it says compounded monthly. So the principal for that problem was 3,500 when you look in the book. Multiply by parentheses 1 plus, and now I'm going to have 0.029, so 2.9% becomes that decimal, 0.029, and now it says monthly, so according to the compound interest formula I have to divide by 12 months in a year. There we go. Close the parentheses, to the power, open the parentheses, and now this is where I have to put the months back in again. So it compounds itself 12 times a year, so it's 12 times the number of years, which is 7 in the problem here. Close the parentheses, and I come up with the correct result of $4,286.70. And again, I'm going to dare hitting the second entry button here, thinking that it might make it quicker for me. We'll find out. There we go. $1,500 for the last one that I want to do. And then I have to go forward, and that's going to be 3.32%, which means 32, and I need another digit, which I insert the 3. And then, oh, and then I lost my divide, so I have to do that. There we go. I fixed it. And then I still have 12 months, and in this case, it's times 30 years. So there we go. And hit enter. And, oh, and then I don't come up with the right number. Why? Oh, this is what happened. There we go. That 2 should not be there. There we go. So 0.0323%. No, that's a decimal, which used to be 3.23%. And now that is the correct number. Now, of course, I could have used my spreadsheet here. So for the first one, I have 15,000 at an interest rate of 4.25% for 5 years. There we go. Again, just like before, the 4.25% right here becomes a decimal by dividing by 100. There it is. And then I'm going to look at 5 years. Here it is, and that indeed is the correct answer. Of course, this is the compound interest column. And when I go up here, this is where the formula is. So there's the principal of 15,000 right here, times parentheses 1 plus. Then this one here is the interest rate already divided by 100 to get a decimal. And then here's to the how many years, in this case 5 years. So there we go, got the right answer there. And this one here is 27,500, and the interest rate for that one was 3.75%, and the number of years was 10. There we go. And so I'm going to go to 10 years. There it is, and that is indeed the correct answer over here. Okay, then I have a couple more, but as they compound monthly, I actually didn't write I didn't put that in my spreadsheet. So in my spreadsheet, you only get the compound interest annually, but not monthly. So I'm just going to go to an online calculator. There it is. Is that the one? No, this is the one. Here it is. And for the last 2 here, what I would have is the initial investment, 3,500. Interest rates on the second to last problem was 2.9%. Let me double check. Yep, 2.9% it says there. 0.9%. The investment length is 7 years. And this time around it compounds monthly. There we go. Calculate. And scroll all the way down after 7 years. There it is, $4,286.70. There it is. I can also click on monthly schedule, then it becomes really long. I think like 7 times 12, 84 rows here, and at the very end, that is the correct answer. All right, and the last one that I have here is $1,500 investment, 3.23%, again monthly, and this time around it's 30 years. There we go, calculate, and yes, that would be, it gives it to me annually anyway. There's the correct answer, $3,947.82. Oh, they rounded different, slightly off. Again, we don't care about that 1 penny that it might be off one way or the other. And of course, if I had done the first 2 problems here, which were 15,000 and 4.25% for 5 years, it would of course also calculate the correct numbers here. Well, why not? Oh, because it kept it monthly. Annually, the first 2 problems were annually, so there we go. 18,470, and again, it rounds differently than what the bank wants, I guess. And let's see the other one here from the top, 27,500. at 3.75 for 10 years. There we go, calculate 39,738, same as this one. Oops, gone. No, I don't know how to get it back. Seriously, I don't know. Oh, there it is. All right, and that's it.